Hey, welcome back. Today we're going to talk a little bit about fourth axis machining. I'm going to take you guys into my CAM program here in just a few minutes, and the machine we're going to be using is my Sile X7. Now, just because I'm using my X7 with a fourth axis rotary doesn't mean you have to. This video is going to cover the basics of fourth axis machining for any CNC machine. Doesn't matter what machine you have. Whether you have a little toy that you bought off Amazon for a couple $100, or maybe you have an Akuma with a great big 300 millimeter rotary, doesn't really make a difference. The first thing I want to get going is that I know that most of you guys here are probably already quite familiar with three-axis machining. That's X, Y, and Z, or X, Y, and Z all at the same time. If you are unfamiliar with the other rotary axes, this is what I'd like you to do. Take a piece of paper and write down X, Y, and Z. So X, Y, Z, and then underneath it write down A, B, C. And that's because the A axis rotates about the X axis, the B axis rotates about the Y axis, and then the C axis, if you have one, rotates about the Z axis. The next row of letters, if you're interested, for G-code purposes, are I, J, K. And so if you're ever looking through your code and you see I, J's, and K's, you'll know that they're linked to the X, Y, and Z primary or master axes that are at the top of the list I just gave you guys. Fourth axis machining isn't incredibly difficult or even that much different, specifically speaking, from three axis machining, as you're going to see when we get into the software. I don't really want to show you guys click by click because software changes, brands change, methodologies change, but the general idea is that it can be incredibly efficient to have a part, to be able to machine side one, flip it over, knock off side two, go back, run maybe a 2D contour and trim it down, and then just kind of flex it or break it off. Or you could take the part out of your vise, run it through a bandsaw. There's lots and lots of ways to accomplish this. But ultimately, it's about efficiency, speed and efficiency. There are definitely applications where you can do things when you have a rotary or several different rotary axes on your machine that can't be done without them. But generally speaking, a fourth axis is just all about efficiency. One thing to be wary of before we head off into the CAM software, there's nothing to be afraid of. When you're normally machining a part and you're coming down in a three-axis setup, generally speaking, you're just trying to make sure that you don't go too deep, you don't run into your vise jaws, you don't collide with anything. The only thing different when you're running with a fourth axis is that you don't either A, go down too deep and crash just like you could with three-axis machining. That's the first step. The second step is you want to make sure that you don't collide with the rotary or any of the fixturing, moving too far in X or Y in the wrong location. So that's the second way. And then the last way is you want to make sure that the tool is up and out of the way when you decide to rotate your part or actually rotate your fourth axis. So with that said, all of the rules that you've already learned from three-axis machining apply. It's all about taking the right width of cut, the right depth of cut, having the right surface footage. Any speeds and feeds calculator that's out there, whether it's G-Wizard or FS-Wizard or HSM-Wizard, they'll do you just fine. In fact, most tooling manufacturers have their own tooling calculators or feeds and speeds calculators. The one thing the feeds and speeds calculators can't help you with is estimating how rigid not only your work holding and the clamping torque of your rotary, but how rigid your machine setup really is. And that's something that only comes through trial and error. So just take that with a grain of salt. This is absolutely doable for anybody. As long as you're patient, you work at this step by step. So with that said, let's head over into Fusion 360 and I'll show you guys a little bit about how I set this up. A little bit of I guess I'm going to jump the gun here a little bit. Every software is a little bit different, but generally speaking, in most pieces of software, what you're really choosing is which direction is Z on your part. So if you're going to cut a part like this, you'll make sure that Z is up. If you rotate the part in CAM, what you'll have to do is just realign the work coordinate so the machine knows which way is Z, and then generally your post processor will handle the rest. If there are problems, and there's different nomenclature for this. It could be work plane, transform plane. It could be, for instance, in Fusion 360, tool orientation. You just click one button and choose which way is up, and you're off to the races. I will say one thing to you guys before we head into the CAM software. Even though I'm using Fusion 360 and I started using it for my business full-time a couple of years ago, I don't really endorse it. I don't know that I would do it again. In fact, I think it was probably a mistake to migrate to Fusion. I liked the idea of the whole networking and team setup. I didn't realize how many workarounds I would have to come up with. I didn't realize how many times there would be little gremlins and issues and things like that. And so I would implore you to research carefully before you buy or invest not only your money, but your time in any software for your business. There's an old saying, big doors swing on little hinges. And I really do believe that the software or the technology you choose to service your business on the back end is really, really important. So, all right, I'm done babbling. Let's get over here into the computer. All right, here we are inside Fusion 360. I've got a few different setups here, and I'll explain these to you here in just a few seconds. This part was just designed for this demo. I just wanted you guys to see how this works. There are a lot of factors that need to be considered when you're making parts on any given machine. When you get too far from the face, you see I've got this little, this is construction geometry, this axis right here. But when you start getting really far from the face, you're going to have a lot of wiggle. And you're not going to be very rigid out here, which is why you see other companies that sell things like A-frames, or they sell things that are like rotating platens, almost like trunnions, kind of like beds. You'll see important cylinder heads and things like that sometimes, even on fourth axis machines. But here we've just got this little part right here, and just for some perspective, let's see here. Let me see if this will select the edge. Go in here to design. And this is 1.574 inches. If you hit I, it'll tell you. You can choose a secondary unit for you guys that are not. That you guys don't like those America units. And it looks like it's drawn at 40 millimeters. So this was actually drawn at 40 millimeters. I drew this quite some time ago. So 40 millimeters. Let's see if this one will tell us what this one is. 24 millimeters tall. And let's see if we can choose these two faces and see. It'll tell us exactly how big this is. Yeah, 35 millimeters here. So just for reference, just so you guys can see. Okay, now you see we've got the axis here, which is the center line, and you can hide this in the construction tab. So let's get in. Let's go ahead and get into. I'm going to leave the axis there so you guys can see it, but let's go ahead and get into the manufacturer tab. You know what? Before we get into the manufacturer, I guess we're there now, but. You would set this up just like any other part. And I want you to see that I've got a whole bunch of different work offsets here. And one, we're basically using the edge of the part. There is no, let's just say, right or wrong way to do this, but there are lots of different ways. And so this way, you'll see that when we open up this setup, each toolpath is going to use the center line of the part for its origin. So if we just click on one, and then I'm just going to arrow down, you guys can see that we still have, you notice that now the Z is facing in the other direction, so the part would be indexed, but the Z is in the opposite direction, but the X still goes toward the rotary, and same thing. Now it would orient in this direction, and then it would orient in this direction. And so I'm just going to show you guys real quick. We're going to go ahead and choose this. And this is centerline programming, probably the most common way to program on a fourth axis. And so we'll just go down here and we'll speed this up a smidge. And for the record, this isn't the perfect way. This is just a way. And so I'm going to go ahead and dump the toolpath so you guys don't even have to see the toolpath at all. And you'll see that it's just going to go in here. It's going to clean this up. That's going to go down here again. Cleans it up, flips it over. Yeah, that was probably a little bit faster than it needed to be. Let's go ahead and do that one more time. What we'll do is we'll just hit play. Okay. I'm just going to go through this toolpath by toolpath. So the first, we're going to run through the facing operation. Done. By the way, if you go over here to statistics, it'll tell you all the specifics about what's going on. It'll tell you the name of the toolpath that you're running. So the first toolpath, done. Then it's going to go ahead and it's going to run an adaptive, and that's going to flip over. It's going to face this off. So we'll flip this over. We'll hit go. Now, obviously, this is not the best way to do this. I'm just showing you guys this for demo. Truthfully, if I were going to do this for a production part, I would cut down a little bit deeper right here. And then when I flip this thing over, I would just do one medium speed 2D contour around this thing and just cut this whole little ledge right off. I wouldn't actually do this facing up because this is a little bit sloppy, but here it goes anyways. So it's going to come across here, and it's just going to go ahead and cut it off. And just so you know, when we actually did this on the machine, I did it just like this, but it sounded a little sketchy, and obviously out here at the end it's flapping around, but it's just aluminum, so I wasn't really worried about it. So now we're going to come back in here, we're going to run the 2D contour. On the inside, we're going to bring the parts outside on dimension. Just to show you guys that the work offset was right, notice that we ran a 2D contour down from this direction, and then we ran one basically at A180, at A180 degrees. The only reason I did this in this part is because I wanted to show you guys that once you have your work offset set super accurately, this will blend together beautifully. In a perfect world, you never want this to have to blend. You'd rather just take your 2D contour right here around the bottom of the part once, and then you would never need to actually blend two tool paths. But this is, like I said, this is for learning purposes, so I hope you guys are still with me on this. So now it comes in, does its drill, rotates again, does its other drill, and it's done. And that's that. And this is a really fast part, okay? So that would be centerline programming. So let's put that away now. Now, if you... I'm trying to think of how I would explain this. My post, I was having some issues with it, okay? And so what I did was I set the part up like this. And then I trammed in the 4th axis to 0 degrees on the A axis. And then I set 4 different work offsets. So if you look, when I hit edit right here, you'll see over here that this is post work offset number 1, G54. This is work offset number 2, G55, G56, G57. I did that because my post was kind of goofy and it wasn't really working the way I had intended. The reason I decided to leave this in here is to show you guys that if your post isn't working, this is a great way to work around having problems with your post. You can just set your stock up just like this, make this G54, make this G55, make this G56, and make this G57, and boom, you're off to the races, even though you don't have a post that is working the way you want it to work, okay? If you're an experienced machinist and you just watch that, please keep in mind there's a lot of guys that come and watch these videos that are just getting going. They don't know how to edit their post. A lot of these guys are having fun and they're just playing in their garage, and it's not worth it for them to spend $500 or $1,500 to have someone professionally edit a post for them. So, all right. So I showed you guys the primary way, which is using centerline programming. Let's get into the toolpaths real quick just so you guys see the actual mechanics. So we used the work offset, the WCS, the work coordinate system, from the setup in the first toolpath and in the second toolpath. But in the third toolpath, notice we don't. And so what you do is you go in there to edit, and in this particular one, you just check this little box. See, normally it would be using the work coordinate from the setup, but when you choose tool orientation, it allows you to change this. This will then be interpreted by your post to rotate the part. And it's that simple. That's literally how simple 4th axis is. And by the way, many of these toolpaths actually have this feature enabled on them. And there's some really cool stuff. You can't see it here, but if you get into some of the 5th axis toolpaths that are available, like let's just say, I don't know, that's probably not the one I want to use. Let me see here. Which one would be better? Maybe contour. Let's see if we can just add a contour here real quick. Choose this. Tool orientation. Check this out. Align to view. So if you had a specific angle or you wanted to reach down to hit something with the edge of a ball mill, you could just look right down at your part, position it with your mouse or whatever you use, hit align to view, and now look, when you hit OK, it automatically aligns your work coordinate system to your view. So I know that's a little bit advanced. That's not part of fourth axis. At least it's not part of traditional fourth axis, but it could be used. And so it's a really cool feature that's in there that I have used on other parts. You guys have seen me cutting the aluminum stuff for like vacuum forming molds. I use that stuff, but that's it. That's really the basics of it. You set up the center line. You run through the mechanical operation of setting the part up on the machine, and then you go in and you choose your tool paths based on the work coordinate from the setup. And anytime you have something that you need to set up that you can't reach from your original work coordinate, say like this hole, you come down here, you hit edit, and just so you know, it won't actually let you choose this drill face right here until you change your work coordinate. So look, if you look, watch, it won't let me even choose that. I'm clicking on this, it won't even let me choose any of this, but it'll let me choose this because it matches the work coordinate. So when I click tool orientation and then I select an edge, which has already been selected, now when I go up here to my geometry, now I can select whatever is congruent or parallel to the z-axis. So it's really pretty straightforward. And if something's in the wrong orientation, say your x-axis is pointing the wrong way, there are buttons to do this. And so that's it. So this is how simple it is. Now the next question I get is like, how do I like not hit the vise, Jay? Like, man, I'm doing this, I'm selecting all these things, and my tool paths all want to hit the vise. And there's probably a lot of ways to do this. I'll just show you how I do it. Down here in models, I'm gonna open this up. If I turn on sketches, you can see that I've got a bunch of sketches in here. These are just boundary sketches. And so what I've done in one of my setups, we'll go in here and we'll just choose like this adapter right here. Let's look at the top. You'll see that I've chose a sketch to basically contain this toolpath, and that's it. That's all there is to it. So when we hit edit, you see it's got machining boundary selection. You can see that it's already been selected, and that's that. That's all there is to it. And then the stock is the yellow for what's left, and that's that. And it's contained in it, and it does its job. And so that's it. And that's all just done back in the design workspace. So back here in the design workspace, I just went in there and created some sketches. And then when I was programming in the manufacturer workspace, I chose my part geometry as I saw fit, set my depths, my feeds, my speeds, chose my tools, and then I just applied boundary conditions to make sure that we didn't run into anything else, like any of the fixturing. So just so you guys know, when you're actually running a sim, if you guys saw this, you guys saw that when you're running this, if this thing were to take off and hit the vise or collide with the vise, when you're doing your setup up in your original setup, notice that this has all been selected under fixture. That way, if the end mill or anything hits any of this, it will notify you in your simulation. Okay, so all right, last but not least, so this is Centerline programming. The other way to do this is basically like this. This is what I would call like an in process. So let's just say you let's just say that you don't want to use Centerline. You really don't care, right? This is a quick and dirty setup. You're going to slap the fourth axis in here. You don't want to set it up for whatever reason. Maybe you don't have room. Maybe your work holding is just super sloppy. You're just going to go ahead and you're going to pick up right here on the corner of your stock. You already know exactly how much distance there is from your vise jaw, so you've verified everything. So you take your first couple of cuts, and now you have your part left. Well, when you wrote, this is just going to be a completely different work offset, and you may measure from this edge. You can do whatever you want, but notice the Y value here. If this hole has to be perfectly in the center of this part, if you ran this as G54 and ran this as G55, if your machine was in a shop that, say, is not thermally stable or maybe it's just generating a bunch of heat because you're just running the spindle at full pull for hours on end, and your head grows, and so your y-axis begins to deviate. All you would have to do is change your G55 Y offset by a very small amount, and you would be back to putting your hole right in location. So just keep that. There's, like I said, or obviously there's nothing stopping you from taking a deeper cut somewhere else, but that's the gist of it. So I hope this made sense for you guys. There are so many different ways to kind of skin the cat, if you will. I do believe that centerline programming is the best way to do it, or most reliable way. But there are definitely times when I think it makes sense to run multiple work offsets, especially if you are really trying to hold something with a really tight tolerance. By the way, the only other way you would run, I had another setup in here, and I was going to show you guys. If you guys needed to run something that was fourth axis simultaneous, let me see if it's in here. Sorry, most of this stuff is actually work stuff in here. This was an earlier version, a little bit sloppier. See, it's got a mess going on here, but we'll put this away. But you see this right here. This was just so that I was going to show you guys how to run a fourth axis simultaneous cut. But for whatever reason, I just need to get my post sorted out. So maybe our next fourth axis video, we'll talk about actually doing full simultaneous work. So, all right, that's that. I appreciate you guys watching. Hope you guys learned a little something. This is pretty straightforward. Most of these softwares make this easy. And the real trick is just finding the center line and being patient. Just kind of clicking your way, working your way through each setup, each toolpath, each surface, and each feature, one click at a time. I hope that made sense to you guys. Fourth axis machining doesn't need to be super intimidating. There are lots of possibilities, and with some of these newer generations of fixtures that I'm seeing out here, where guys are taking a fourth axis rotary and then adding a secondary C-axis to it for kind of manual 3+2, the sky is the absolute limit. Technology moves forward each and every day. Machines get more accurate, they get faster, software gets easier to use and less costly. And I hope in this video I showed you guys just a few tips and tricks. I never claimed to be a Jedi Master. My philosophy in general in life isn't to learn everything, it's to learn the things that I need and get a strong enough grasp on them so that I can apply them for benefit in business, pleasure, hobby, whatever. So thanks for watching. We'll see you guys in the next one. Bye-bye.